Our next portion of today's agenda, we're covering STEM activities from institutions around the state. And the first set of presentations will come from NDSU. I believe Brian Slator is the first speaker.
Actually, we've changed all of that. Demonstrating the flexibility available with cyber infrastructure, we've decided to sort of reset the order a bit, and so I'm going to be speaking first, and I'm actually Bob Pieri. I'm a mechanical engineering professor at North Dakota State University, and I'm not on the agenda, but we can forward some of our information. And I'm here to talk about a pre-engineering initiative that we're doing with the tribal colleges. And it's interesting because I was just talking that I was teaching from the same room that the folks from Turtle Mountain were presenting. And so one of the things we're doing at North Dakota State is we're actually reaching out to the tribal colleges in a pre-engineering program sponsored by NSF to go out and work with populations on reservations to get them to see the value and to take the academic steps to get ready for an engineering career. We go out and teach a number of courses above their basic curriculum, sort of introduce the college to them, let them see what the opportunities are and avail themselves of that option. As we go about, one of the important things about it is to provide student support for what we're doing so that we actually can enhance the personal connectivities, the out-of-classroom support options to it, and although infrastructure can do a long way in terms of the technical applications, sometimes it's a little less effective to actually go ahead and do connectivities with individuals and get them to understand. Jokes don't transmit well on Ivan connections. So we go around and do classes with them. We broadcast this semester between Turtle Mountain, Fort Berthold, and Chindeska, Chicana, and we run the class twice a week. And we're also doing an AutoCAD lab with them to demonstrate what's available. The cyber infrastructure comes into play because we can actually go back and forth, ask questions, relate some material out of a textbook, be able to respond to students' needs. For example, we had a session a couple days ago where we were doing binary, octal, hexadecimal numbers, and by being able to sense what the student's reaction to that was in a physical stance, the eye, facial expressions, we were able to go back and readdress some topics that they may not have been catching the first time. And it was a much more effective way of getting the point across than just being the sage on the stage and talking to the little camera in front of us sort of deal. So the cyber infrastructure can start introducing some technical concepts to them. We've actually been reaching out to the tribal colleges for about 11 years at NDSU, going out and taking this program on the road. And from day one, we've involved the Ivan system that we have in the state to do the broadcast. By bringing it up to the cyber infrastructure level, we feel that it's able to bring us to the next level where we can actually start incorporating some of the hardware in our presentations and get the students a little more involved. We also think that we can take the educational aspect from a synchronous program to an asynchronous program and allow learning to take place when it needs to as opposed to when we've got it scheduled on a calendar. So these are some of the options there. My colleagues have asked that I sort of talk at length about this, but I think I've probably influenced you to taken too much of your time already, and at 11 o'clock I'm going to have to leave to go off to a tutoring session in our multicultural center and work with some students on that. But I thought you should hear about that we're actually using a portion of the cyber infrastructure to actually communicate an educational process as we go. So I think what we're going to do now is go with the electron microscope, if I'm correct.
Thank you. My name is Scott Payne. I'm the Assistant Director of the Electron Microscopy Center here at NDSU, and this is Jayma Moore. She's the Laboratory Manager. We represent the Electron Microscopy Center. Our physical location is actually 5 blocks from here, and it's in a USDA facility. It's about 3,500 square feet, and we have about $3 million worth of electron microscopy related equipment housed in that building, and including 2 transmission electron microscopes and 2 scanning electron microscopes. And what we're going to talk to you today about is our scanning electron microscope that we can operate over the internet. You're basically wondering what is electron microscopy and how is it related to cyber infrastructure? And we were wondering that too, and we came up with a few different things. Basically, electron microscopy, most everybody, and this is where we do a lot of tours and we're looking at a group, and I'm not really looking at a group, but everybody nods their head, either they do or they don't. They've used a microscope at one point in time, either a hand lens to take out a splinter out of your finger, or in middle school or high school or even college, a benchtop light microscope, right? So what's happening there? Light is interacting with the sample and interacts with the sample and goes up through optics and is magnified, so you can increase the size of an object. Okay, with an electron microscope, and that's pretty basic, and with an electron microscope, it's the electron that we use, the electron's wavelength, which is infinitesimally small, to interact with that sample and give us much better information than a common light microscope. And if you're looking at, I'm assuming you're seeing our scanning electron microscope there on the slide. The maximum magnifications we can achieve with visible light and glass optics in a light microscope sense is 1,000x. Okay, and that's basically where we start with the electron. The electron is so small and gives us such a small interaction that we can increase that 100-fold, if not more. And what we really gain with an electron microscope is depth of field, or how much we can keep in focus at any given time. Basically, we give you the 3D structures, as you're seeing now, that you've probably seen. You're probably saying to yourself, well, I've never seen a scanning electron microscope image before, and you have. It's the black and white images of fly eyes, insects, those types of things. You've probably even seen them on CSI. Okay? It's pretty basic. Now, they're expensive pieces of equipment. We purchased ours in 2006, this particular model in 2006 for $300,000 with an NSF Major Research Instrumentation grant to do just this, to do research and provide outreach. And that's what I'm going to talk about a little bit about today. This microscope basically gives you surface views of samples. Anything from fractured surfaces of metals to insect eyes to plant surfaces and everything in between. It's a workhorse microscope, meaning that in the last 5 years, we're above 10,000 images stored. Okay? It has a magnification range of 20x to 50,000x, so it does cover the light microscopy realm of 10x or 4x to 1,000x. We can also provide elemental analysis, and this is primarily used as a university research tool along with some teaching interactions. Now, you're probably wondering what the cyber infrastructure portion of this is. And that, we had to think about this a little bit. We knew one aspect of it, and that is our remote outreach. The other aspect, though, we use on a daily basis and we don't even realize it. And that is, prior to 2000, we stored all of our images on optical disk drives. Okay? We generate with this instrument, between 2,000 and 3,000 images a year that we need to archive for each individual researcher and be able to pull those out at any given time and maintain that archivability. Okay, what I mean by that is when we were working with those optical disks, we had at least 3 that I know of go bad, have a bad sector on them, you can't read them. We would then lose that data. Now what we have is, thanks to Dr. Greg Wettstein and his group, we have a research storage facility area where we have, I think it's a RAID server that's backed up daily where we can put those images and they're maintained and that integrity is kept there, and it is also very secure. So